but it is actually a relatively easier concept if you look at it. So let's say I'm using ChatGPT or any of the chat application that uses a large language model. And as a user, I'm asking a question. So what it actually does is it will try to find an answer to the question that I'm asking. So these models are already trained on data that we have, that is already available in the Google or in the web, right? So as it is trained with the data that is available in already in web, it will try to come up with a response to it. So, but if I just go and ask Chat GPT that I have a database in my local machine setup, and I want to write a query and ask some questions related to the data that I have in my local, then it won't be able to answer it because it does not have access. So, what we usually do is we set up a database and restrict some access to the LLMs. So, what we do behind the scenes to get access, to give access to these LLMs to get response to the data that is present in our local is, so the first step is the user is asking a question, and let's say that I have a database set up in my local. So for this particular question, I'm going to retrieve the related data from the database. That is the first one. So once the data is retrieved, it is going to something called as a generator that is going to generate the response. So the word augmented means making it better. So I'm going to make the chunks that I've retrieved from the database. Chunks meaning the data that is, or we usually refer to the chunks of documents. So it is just nothing but data in detail. So the I'm going to pass these chunks to something called as the generator and make it better. So in our case, the generator is going to be the LLM. So retrieval augmented generation is nothing but I'm going to retrieve some data from the database and generate a response related to the chunks that I've retrieved and make it a little bit more better. So coming to the topic, today's topic, which is text to SQL. So what is text to SQL? So it is nothing but you're just going to convert the natural language into an SQL query, right? So why does it matter? We have a lot of use cases in today's world for text to SQL. And one of the basic use cases, let's say that you are a BA working in a project and you have a question in your mind and you want to run an SQL query and retrieve the data. But right now, the SQL is not listed as one of your skills. So you want to ask a developer's help for the SQL query, but unfortunately, none of them are available. To unblock yourself, imagine that you have an application already set up where you can just ask the question and it is going to retrieve all the context for you and give the response itself. So that is why we need something called as a text to SQL. And in today's session, we are going to concentrate on the retrieval part alone, not on the generation, because you're going to retrieve the data from the database using an LLM. So generation will not be covered here. So, okay. So before going to this, I would like to show you something. Okay, let me ask something. Okay. So let's say I'm asking the chat GPT or any of the models or applications that you know a question about the database that you have in local. So what are all the information that you need to provide to the question that you're asking? Because it is not just going to be the question, right? So what are all the details that you think that needs to go into the question? Ex- Example, okay. Schema, okay. Sorry. Okay, background information, all the context. Filter conditions, yeah. So this covers a lot of things. Okay, so this is something that we're going to pass to the LLM so it can work better. So yeah, so text to SQL, when you consider a large language model that is trained on a lot of data on the that is already present in the web, SQL query is going to be just a subset of the data, right? So if you look at all the data, then there are also different kind of SQL queries that you can run. So, like, for example, the dialect of the SQL query that I'm going to run in Snowflake is going to differ from the dialect that I'm going to use in the AWS Athena, which is a different database. So that is again a subset of the subset. I just want the tiniest talent that the LLM possesses to create the SQL queries. So we create something called as the prompt, and in prompt we specify all the information that we need, like the instruction, and we set the context that we need to pass to the LLM, and we also give some examples. And the most important one, the user input should be specified in it. So why do we need the examples to be specified in the prompt is something we'll see today. I'll show you a quick demo on how text-to-SQL works in the background, and we can discuss on the challenges that we're facing. Let's stop sharing. Just a minute. Okay. So I have a function called as chat.run, and this has some questions. So before going to that, we'll just try to understand the tables that we have set up in the local. Okay. So since I'm working in a preclinical domain, the tables that I've chosen today is also related to preclinical research is conducted. I hope it is visible. Is it okay? Is it fine? Okay. Yeah. Okay. So there are scientists working with drugs or compounds all around the world, right? And whenever they do some research with all these compounds, they'll do some research. Whenever they do some research with all these compounds, they'll record it for them to refer it later or to publish it. And all these researches, they used to call it as studies. So this table is just an example of all these studies. I just have some mock data. So at one glance, if you look at it, this table has details like the procedures, some alternate IDs, and findings, and we have the start dates and researchers' names and everything. If you look at the column details, it is not normalized properly, right? It is a JSON. And it has a field called as procedure, which is an array. And again, alternate IDs, which is an array. So all these are like complex data types. So this is the um, challenge that we are going to try and solve today. So let's quickly look at the prompt that we have. Yes. So if you look at the prompt, I have specified the SQLite dialect because currently I've set up an SQLite database in local. So I've specified the dialect that we need to use. And the input will be the user question. So whatever the user ask will go in here. And I'm passing something called as table information. So this table information is nothing but the schema of the table. And the schema is very detailed that I've not provided just JSON here. It has the detailed column names and also the data types of all the columns that we're using today. And to add a cherry on top, I've just added an example column. So it will help so the LLM will know how the data actually looks in the database and not just the schema. Sorry. No. Is it- Okay, I might need some help here. Is it better now? Okay. Okay. So the table information here contains the column names, the data type of the column, and also some example column that I've taken from the database. So this is what is going to go into the prompt. And let's see what else I have added. So I've added some guidelines to follow while constructing some complex queries. So this is nothing but some of the rules that we can already see in web to construct the queries. So since the rules for that we follow for each of the dialect differs, I've specified some rules for SQLite. I know that the select, where, join, everything is same, but we have something called as the JSON functions, and that differs. So I've added all the rules so it doesn't confuse with the other rules that it is already trained with. And I've also specified that it do not use some reserved keywords because that is some restriction that we have in SQLite. And yeah, so this is the prompt that we have. Let's just quickly try to run, ask a question to the chatbot. So I'm asking a default question. Like we saw the table, which is the preclinical studies, and we have one more table called as the study results. The table name is wrong here, given as study details. So I'll just remove it. So let's just see and get the count of all the studies that we have in preclinical studies, just to make sure that it is working. Yeah. So it gave us a query, select count star as count from the preclinical studies, which is a correct query. And it executed it in the database, SQLite database, and it gave a result from the database as 10. So this one is working fine, right? If I ask, give me all the studies, yeah. So if I ask, give me all the studies, we saw that the table has like 10. But here I can see the limit is added as 5. And that is because we have specified in the prompt that limit of k should be applied. And the k value is provided in the code as 5. So it has applied a limit of 5 and it is picked the top 5 studies from the database. So on a high level note, the text to SQL here works. So we have an LLM setup and we have a normal prompt setup, and we have also tried asking a question and we're getting some results from the database. So it should work, right? It is not much complex. So we'll just try and ask another question in the database to the LLM and check if it is able to work. I mean, if it is working. I'll just add it here. So find the study name and the corresponding procedure where it matches one of the keywords, and we've specified a filter for one of the alternate IDs. And I've also asked it to sort it by study name. Let's run it. It takes quite some time. Okay. And we got an error. Okay. So though the LLM was able to return a query that looks correct at first glance, when it was executed in the database, it threw an error saying that there is no such column JSON each dot value. So the syntax in the query is wrong. So it is the query is not formatted correctly, right? So if I just go back to the prompt, I can add a rule or a guideline to not use the JSON each and use a better keyword. So, and also I can also specify some examples in the prompt. So it will make it better. So what I'm doing is I've added some examples. And the examples have something on categories. I mean, on using the in keywords and something on group by and order by. But here I haven't specified something on the JSON. So let me just quickly get the prompt. Okay. Yeah. Is it visible with the light theme? Okay. Okay. So I've added one more condition here for handling the JSON data. And I provided an example for using how to use JSON extract. So let me just go back and ask the same question again. Okay. So this time it was able to construct a correct query. So it has the filter that we asked for, efficacy and the alternate number that we mentioned. And it was able to order by the study name that we asked for, right? So this is one case where the user, that is me, who tried a difficult question was not able to get an answer. So we'll be having so many such cases. And for each of the cases, we can't just go back and keep adding everything in the prompt. Agreed? So, what will happen when I keep on adding all these examples in this prompt? Let's say that I'm getting one more requirement or 10 more requirements or 10 more fixes that my clients are asking, and I'm adding 10 more examples in the prompt. So, does it look good? So, the prompt will actually grow longer, right? Longer and bigger. And this will have some issues when we are trying to process. So, what are all the challenges that we are going to face with larger prompts? Okay. Okay. Yeah. So here are the challenges. So the prompt that we saw right now, I'll go back, had an instruction and it was able to set the context correct. And we also provided some examples and we also gave the user input. But still we had some issues generating the SQL query or the desired SQL query. So this kind of prompt where we specify the examples we call it as few shot prompting. And what are all the challenges we face here is called as is listed here, and the first one is context window. So this image might be might be familiar to you if you are using ChatGPT. So when the user asks a long question, like 4, 5 paragraphs, more like an essay, with the newer models, we have the context window has also increased. So previously, when we ask bigger questions like 3, 4 paragraphs, then it will throw a message saying that the question that you're asking for is too long. Can you please make it shorter? So why do we need a shorter message or a question? It's because LLMs have something called as a context window. So beyond that context, if you provide something that it won't be able to process. So the higher the context window, the slower the processing is going to be because you're going to feed a lot of data and it is going to take time for the LLM to understand each of the tokens that you're passing. So it is very important to keep in mind the context window. So what happens when I keep on adding all these examples is it is going to clash with the context window of the LLM. And in this case, we consider only one question. So what if I want to consider the history of questions that the user is asking? And that also needs to be processed. And all these things, if it goes into the prompt, then that is going to be a bigger challenge. So context window is something that we always have to keep in mind. And dependency on static examples. So we saw that 4 examples were mentioned in the prompt, right? And these are static and they are not going to change. So LLM is going to depend on only on these 4 examples to generate the queries. Whatever question you ask, it is going to depend on only these 4 examples that you have provided. And as a developer, if you want the performance to be better, then you're going to think about having generic examples, and you cannot limit the examples to a limited number. You can't generalize all these examples and still expect a better performance. So that is again going to be a challenge. And the third one is inefficiency in updating prompts. Okay. Um, Today, we found that there is an issue with JSON extract. It was not using the syntax correctly, and we saw that it is posing some issues. So we added it in the prompt, and it fixed. So what if we come up with a new requirement tomorrow? So we can't just keep adding it to the prompt, and again it is going to make the prompt bigger and it is going to be difficult to process. So that is why we have something called as dynamic few shot prompting. So, why dynamic few shot prompting in text to SQL specifically is because text to SQL is something that is growing today in today's world, and we saw that dynamic few shot prompting improved the performance of text to SQL. So, before going into okay, I'll just give a quick overview of what dynamic few shot prompting is. So, the prompt that we saw now had 4 examples. And we saw that if we come up with a new requirement tomorrow, then we need to add another example to the prompt, and that is going to be difficult. So what if there is a way by which we can dynamically update the examples based on the user question? So what if the user wants to know the metrics that is used in the study, and I have examples related to how I can construct the query for metrics and dynamically give it in the prompt? Or what if the user wants something related to a complex field, and I already have the example somewhere and I'm able to dynamically give it in the prompt? Is what dynamic few shot prompting is. So what we do here is we have a user question. So in in the GenAI world, we have something called as vector databases where we store all the data that needs to be retrieved by the LLM in a vector database. So vector databases is nothing but you're going to convert the text that you have into an n-dimensional array of numbers or floats. And you're going to plot the data that you have in an n-dimensional graph. So let's say that the user is asking a question, and this question is also going to be converted into an n-dimensional array, and I'm going to plot this question in the vector database that I have. And if I specify the k as 5, I'm going to pick the 5 responses from the databases that is very close to the question that I have plotted. So this is a high level overview of how vector databases work. And I'm picking a list of examples, like 10, 12, or hundreds of examples. And let's say that we're storing it in a vector database. And whenever the user asks a question, we are able to dynamically pick the examples from the vector database and then feed it to the prompt along with the table informations, along with the instructions and context. If we are able to do all of these dynamically, then it is going to improve our performance in generating the query, right? So this is the overview of dynamic few shot prompting. I'll quickly show you a demo of how this dynamic few shot prompting works. Okay. Before going into seeing the response, we'll just quickly see how the prompt for dynamic few shot prompt looks. So here we have again specify the SQLite dialect, and we are again passing the input. So if you look at it, the prompt doesn't look that big, right? And if I just see, then we can specify the top k or the limit that we have already specified in the actual few shot prompting. And then the same table information is passed. And again, some examples are passed, but this time as some variables. So how we are passing these examples is we have something called as a vector DB setup. Let's see. So I have something called as a Chroma, which is another in-memory vector database that we can use for smaller use cases. And I have something called as a semantic similarity example selector. So there are multiple ways in which you can get these examples out from the vector database, but this is something that is provided by the LangChain library, and it is very easy to use. So I've used it in today's demo. Fine. Okay. Yeah. Sorry, I keep forgetting about the Zoom. Just remind me if I don't do it again. Okay. And Okay. So the Chroma is the vector database that I'm using for today's demo. So we have multiple other vector databases too. And in our client's use case, we use the OpenSearch as the vector database. So we all know Elasticsearch, OpenSearch, and that also supports storing vectors. So and that also supports hybrid search, which is a combination of keyword search and semantic search. So OpenSearch is also a very good example of vector DBs. So I'm having all these examples. So let's just, I'm just saying that I have examples. So let me just go and quickly show you the examples. So with the table that we saw earlier, I came up with few questions, example questions, and few queries that might be suitable for these questions. So in this example, we can also add something called as columns, and we can specify the columns that are being queried. And I can also specify the table name as one of the fields in this example. But for today's demo, I'm just considering the question and the query. So if I scroll down to the bottom, you can see like there are numerous examples. And all these examples are different on different columns. So here it is on keywords, here it is on procedures, but they both use the JSON extract. And different questions are also given. So what we do with these examples is we store it in a vector database. In this case, it is Chroma. And from Chroma, we are going to try and retrieve it with the help of the question that the user is asking. So in this case, I haven't specified the column name and the table in the examples that are provided because this is a very normal case where the user is going to try and retrieve specific columns. But if the user is a layman and they don't have any context about the tables that we have in our database, like the column names or the tables that we have, then it is also crucial to provide the table name and also the column names in the example. So that is also something that we need to remember. It differs from use case to use case. And let's go back to the Chroma. Okay. So here I'm using Chroma and I have configured some embeddings. So embeddings are also models. So here I'm using the text embedding 3 large model that is provided by OpenAI. And as you can see, this has a dimension of 1536. So whatever text I provide to the text embedding 3 large model, it is going to convert it into 1536 dimensional array. And that is not going to look good when we plot. But it is going to capture a lot of informations. So this text embedding 3 large also comes in 2 dimensions. One is 1536 and the other is close to 3K. I don't remember the exact number. I think it's 3072, just the double of this. And let's go back to the database. Again, now this semantic similarity example selector is nothing but uh, it is just going to run a similarity search on the vector database that we have and retrieve some examples for us. So here I have provided the example count is 2, which is actually very less for this use case. We can also change it depending on the size of prompt that we have. So we can also have it as 5 or 2 or 10 depending on our use case. And if I go back to main.py and let me just run the same question that failed when we used few short prompt. Okay. So I have printed also the examples that was fetched by the semantic selector. And here we have an example related to the keywords using the JSON extract. And another example related to the keywords, again using JSON extract. Okay, yeah, here it has a join condition and this one doesn't have a join condition. So that is the difference, but both the examples are very similar. And with these right examples, it was able to generate the right query and it was also able to fetch the five examples, five records that we were actually looking for. So if I remove the limit, it might also have a lot of data, but because of the limit, it fetched only the top five results. So this is how dynamic few shot prompting works. So in a nutshell, dynamic few shot prompting is when we are able to dynamically fetch the examples and feed it to the prompt for better performance. I'll go back to the slides. Okay. K is equal to 2. Okay. So there is an algorithm in machine learning called as K nearest neighbors. So K nearest neighbors is there is multiple ways in which you can find the chunks that are similar to the question that you're asking for. So since the dimension of the vector database might differ, it might be like 1500 or 3000, right? You have different search methods. So one is like cosine similarity. So you will use the angle between the two chunks, that is the question you're asking, and the data that is already present in the vector database. And with that angle, you're going to fetch the top, if k is equal to 2, the top two chunks which are closer to the question that I'm asking. So k is going to be the top number of chunks that are present to the question. Yeah. Okay. So coming back to dynamic few shot prompting, this slide, maybe if we look at it now, it might look sound a little better. So we have a question, and with the help of the question, we are making a query to the vector database that we have set up. And from the vector database, we are going to retrieve few examples that are very similar to the question that we have asked and feed it to the prompt. So this is dynamic few shot in a nutshell. So yeah. So we're open for Q&A. So if anyone has any questions, I should pass the mic. Just a minute.
Just I have a doubt that is it necessary? I mean, is it something that we need to set up vector DB before starting up our query?
Yeah. So if we are considering RAG, like, is this question related to RAG or the text to SQL use case that we are discussing?
No, I mean, I'm related to text to SQL.
Okay. So
Because
for
it is generating some examples, right?
yes.
So is it something that we need to predefinedly give all the
Yes.
examples whichever user might
Yes.
ask?
Yeah. So examples is something that we have to come up with, because the exam, if we ask the LLM to again create the examples, then we might not know if it will work or not. So that is something that we have to curate. The data that needs to go to the LLM is something we have to curate. And vector database is also something we have to set up, and then we have to store the examples there.
Okay, along with the tool. We need to set up the vector DB with all set of possible questions, and we need to
Yes.
implement before the. We need to implement all this DB setup and everything before we give the application to user, right?
Yes.
Okay.
This might be out of the scope,
Mhm.
just out of curiosity. So,
Okay.
the LLM, when you give chat.run, it gives the query. And
Mhm.
how do you execute it and get the results? It's something like a function calling, or
Yeah.
okay.
So I'm doing it behind the scenes in IntelliJ using Python. I can share my IntelliJ screen back again. So I've set up an SQLite database in my local. So you can see that we have something called as preclinical data and something called as study results. So all these data were curated in my local. And how I make the call is, if I go to chat, execute query. Okay. So you just have to initialize a connection to the database that you have created, and it comes up with some functions to add data and execute the query.
Yeah, thank you.
We need to connect with other databases also in case you want to connect with MySQL or.
Yeah. Yes.
But how does this application has a connectivity?
application has connectivity.
And I mean, how does this? I mean, you have this SQL repository code, right?
Yes.
How does it connects with other SQL? I mean, in case of credentials, so we need everything we set up here.
Yeah.
Okay.
So this is actually very basic setup. So there is one setup we have with AWS Athena. So whenever you make a connection, you will come up with a connection stream. So you have to pass in the credentials and the port number and all the details you need for the connection.
Okay.
And one thing that we need to have in mind while running text-to-SQL is if you are giving access to the prod data, and let's say that the user is running, asking to delete the table preclinical studies, it will also do it, right? Because if I ask the LLM to create a query for delete, then it will also create for delete. And if you are let's say that you are restricting delete, then the user might also ask something to insert a record or update some of the records that are already present. So it is very crucial to manage the access that we are giving to the application. So you can manage it via prompt, but even if you specify it in prompt, it is not going to be 100% effective because LLMs can also hallucinate, and it can also, in some cases, it won't consider things that you give in the prompt as well. So it is very crucial to manage the access that you're giving to LLM applications.
Use a guardrail kind of thing for
Yes.
deleted.
So for the demo, I haven't implemented any guardrails. But for client applications, if you are using Terraform to create the resources and manage connections, then you can access the permissions via IAM roles. And different guardrails are there for different kinds of applications. So it is always good to have, no, it is a must to have guardrails when you have text-to-SQL implemented using LLMs. Just a minute.
So we are creating embeddings right here.
Yeah.
So let's consider we have this example question and examples. So what if we ask a question that is out of the scope? So here we have used SQLite.
Yes.
So by some chance, let's consider we have something with Postgres. So does it hallucinate, or does the let's consider this OpenAI model replace with I don't have context to this, or what I'm asking is if it
is out of context, then what should be the response is the question.
yeah.
Right?
If it limits the context only to the embeddings, or does it go beyond the context?
Okay, so one thing to understand is LLMs can hallucinate. So I'll give you a practical example. So I'm working for a client who, like a pharmaceutical client, and we are currently building a chatbot for the client. And text-to-SQL is something that we have implemented. Okay, and the data that we have is actually stored in AWS Athena and not in SQLite. So SQLite is something most people use commonly. So the data that is available for SQLite is more than the data that is available for Athena. So what happens is when we consider the subset, it is the query generated for AWS Athena is not very good with few short prompting. So even if you provide examples, generic examples, and even if you give all the rules, it will somehow fail one way or the other. So there is always going to be a fault. And you know what is the major issue that we've dealt with is when we ask it to generate a query for Athena, it will generate for SQLite or Postgres or Snowflake. It will come up with keywords that doesn't work with Athena. So that's why we explored the concept of dynamic few-shot prompting, and that gave us better results because then you have the liberty to pick the example that is related to the question or related to the question. So it will help us to create a better query. Does this answer your question?
Yeah.
Okay.
So I have a doubt. So we are doing the dynamic short prompting because of main reason is context window is one thing. Another one is the static examples, right? So we're trying to filter on the static examples. So if we take a subset, right, we are trying for if you have say n number of I mean, thousands of examples, let's say we feed it in. But for a particular case, you will have like 5 examples only in our database, right?
Yes.
So my query would be in that case. So if you have a little, our query might be a little variation of what the examples is could be, or it could be a conceptual of all 3 or all 4 of the examples that we stored. So in that case, how is the efficiency or the how is our mileage in that case? Like, does it able to solve in that scenario also? I mean, what I observed is the more static examples you give, it starts to decay, is what I would say. In the sense, like, it tries to not give a nice results out of it, I guess, because it tries to follow the rules
Yes.
strictly on that. It doesn't go out of it or
Yes.
think more, I would say, right? Because it's trying, because we are the ones who putting in a box basically, right?
Yeah.
So what is your mileage in that case?
Okay. So we have, okay, this table that we have, right? This is actually very similar to the table that we have in our production. So you might actually see the complexity of the data that we're dealing with. It is a very complex data structure. And we have 2 to 3 columns in a single table with this structure. And what we usually do here is we'll give an example for each of the columns. And the table information will not just consider, will have the column name and the data type, but it also have something called as the description. So description gives it an idea about the column that we are asking for. So now when you pass the table information, it will also have context about the column name along with the description. And again, if I'm giving one example for details and one example for findings, it is going to look in the vector database. And in vector database, the searching works in terms of vectors or numbers. These are n-dimensional vectors. So whichever chunk that comes close to it, it is just going to pick it. So when I mention whichever chunk, then it is going to be an example related to details and also the example related to findings that is just going to come close to it. So these are like different examples that it is going to fetch, right? So in this case, what we found is it actually, the query generation improved better. So first we started by using GPT-4o model, and GPT-4o has very good feedback on how, on answering smart questions, I'd say. And we figured that Claude 3, 5, or the Claude models have better programming knowledge. So it writes codes better. So this is also a matter of the model that you're using. So, and also the information that you're passing, not just the examples. So there are multiple factors that you need to consider. So what we, it has been in prod for a few days. And what we observed is like this setup works better than few shot prompting.
So to summarize things, like you have examples for the procedure and the findings separately.
Yes.
Even if you mix and match, it's able to figure out from the examples that you've given, and then
Yes.
it's able to provide it.
Yes.
So thank you.
Yeah. And one thing to add is the example doesn't just contain the question and the example query. So here I've just mentioned the question and the query, right? We have something called as description that describes what is happening with the question and the query, and also a line for the columns that we are using. So if this is about this particular column, then why don't you just pick this example? So it should know that, right? So we specify the column name as well, and also the table name. So in case if you have multiple tables and if you want to have text-to-SQL, then it is also crucial to mention the table name in the examples that you're providing.
Makes sense. Yeah. Thank you.
Okay. Just a minute.
What happens if the table structure changes? Will the vector DB knows that a table has a different structures, and
No.
will the query get executed?
So it depends on how you are passing the table information. So let's say that I am again dynamically getting the table information from using a describe statement, then it will know that the data type has changed, but still the example that you're providing will not change because that is something that the user is entering, right? But if in this case, in the demo, the table information is something that I had in a file as a string. So if I change the table structure, then there is a dependency on the information that we're providing in the prompt too. So we have to modify it in all the places.
Okay, in vector also, right? In vector DB.
Yeah, in the examples that we are specifying also, we have to change.
Okay.
I use ChatGPT to write code in Python. So basically, when we prompt, we necessarily don't write in a very Pythonic way. So how does that apply here? Like I see the queries are all more like a SQL. It has more sense when you write the questions, right?
Yes.
So if I'm not an user or if I'm not familiar with SQL, I might write the query in very normal English. And how does that work?
Is I don't get the question correctly. Sorry.
Yeah.
Example queries. Yeah.
So here, if you see, you mention the keyword efficacy, like even all the queries, all the questions are very sensible in terms of SQL query. But when you use ChatGPT for a Python code, you just type like what you need in normal English, and it still understands and gives you the code.
Yes.
How does that, or what kind of performance can I expect from this? Basically, if I write normally, because we are anyway giving the schema, and we'll
Okay.
give the meaning of the connection or
Description,
the
yeah.
relationships, and I can simply write I need this from this, something like that. Will it give? Oh, yeah.
Sorry.
Yeah.
Okay. So it again depends on what we are feeding in the prompt. So it also depends on the examples that I'm giving. So if I go to ChatGPT and ask for Python code, then the amount of information that I'm feeding to the ChatGPT also affects the Python code that it is writing, right? So if it is, if you ask for a particular error, then it will be able to answer the error. Sometimes it will hallucinate, sometimes it will be to the point. But if you ask for it, ask it to develop a whole website or write a file, the whole file, then it is going to hallucinate because if you don't provide sufficient information, it is going to assume things on its own. So whatever goes into the prompt also matters.
Yeah, but I agree. But these days, even if you give a very ambiguous code, not like a prompt, just I need this, it gives you a good code. So that's why I'm asking how, because I don't have any experience with SQL, so I may not be write the prompt as you write. How that will work for me? That's the question. Yeah.
Okay. So, yeah. So, if this is an SQL query that you're asking to the ChatGPT, then again, you have to specify at least the table name and the columns, right?
Yeah.
So, things like the data type should also be specified. And whenever the model, a newer model is created, the performance of the newer model is going to grow. So when we had GPT 3.5 Turbo in place, like last year, the performance of GPT 3.40 is like more than the performance of GPT 3.5 because the training data for them changed or increased, and the way they trained is also increasing. So it again comes back to the data that it is trained on. So for example, I'll give you a homework. Okay, so since we're also short on time, can you try imagine a database on your own and try asking the GPT to generate a query for it?
Yeah, I'll do that.
Yeah.
Thank you.
Okay. Any other questions?
I didn't get the reply you gave to this question. Yeah, I mean, you asked about the normal English we frequently use it. For example, here it is get the top 5 studies with the keyword.
Okay.
Efficacy.
Mhm.
In the word, the quotes you have given it, right?
Okay.
So, in case if I'm writing in normal English, I want top 5 studies
Mhm.
with the word like efficacy.
Okay.
What happens? The English changes, and how does the result come? That's what your exact question, right?
Okay. I got the question. Sorry for getting it confused. So here the keyword is actually one of the column names. This one. Where is it? Keywords. So
That changes. I mean, if you are writing
yeah.
exact word you want to semantic.
Yes. Okay. So that's when I answered his question, there is something that is mentioned as description, right? So what we face in the real world is we have something called as compounds, and each of the compound is used to in a study for testing. So this compound can be mentioned by the client as a drug substance or just a substance. So these are like alternative words or synonyms, and large language models are trained to understand the normal English words. So it will be able to semantically relate, but not always to the point. So it is crucial for you to provide the description for the columns as well.
Do something instead of nothing. I mean,
Yes.
so results, if you do write something to understand,
Yes.
try to get some result. It's closer to the exam.
Yes.
Okay.
Sorry.
You're on? All
Any
right,
other questions? Good read.
right. Thanks, Bernice. Thanks for that. Our next talk is about View Transitions API by Danny Akash. But before we do that, we'll take a short 10-minute break. Right? Tea is served in the pantry. Please help yourselves. But before you go, you see the aisle over there. In the whiteboard, they will put a